Welcome back to the Deep Dive. Today, we are strapping in for a very specialized journey out into the blue. For anyone who operates or, even dreams of owning a boat in the U.S., reliable connectivity is not a luxury anymore. It's become a core utility. We're talking about navigation systems that need live weather data, crews that rely on real-time communication, and let's be honest, people expect to be able to stream high-quality video, to be on video calls, even when they're hundreds of miles from shore. Okay, let's unpack this. Our listener sent in some really comprehensive sources detailing the nuts and bolts of how you get reliable internet in a maritime environment. So our mission for this deep dive is critical. We need to really understand the unique challenges of being at sea, the three core technologies, that satellite, cellular, and dockside Wi-Fi, and why blending them into an intelligent hybrid system isn't just a nice to have, it's really the only way to get dependable connectivity.
That blended, intelligent approach, that's the key insight we want you to walk away with today. What we call marine internet is just a fundamentally different beast from what you use at home or in the office. It's a specialized solution. It's designed specifically to compensate for a boat that's always moving, to withstand these really harsh conditions like salt spray and UV light, and most importantly, to operate as you move between different connectivity zones. That's something land-based networks never, ever have to think about.
That sets up the central puzzle perfectly. Why can't you just, take a home router and a 5G antenna, strap it to a boat, and call it a day? Why is the sea so different?
It really boils down to physics and the environment. I mean, on land, everything is stationary. At sea, you have constant, unpredictable motion. You've got swells, you've got sharp rolls, and that severely impacts an antenna's ability to maintain a stable lock on a satellite or a cell tower that's miles away. And then second, you have physical obstructions right on the boat itself. Masts, radar arrays, rigging, all of that can block the line of sight signal. And then there are the elements. Salt water is incredibly corrosive. So standard electronics, they just fail, and they fail quickly. And finally, the coverage zones are literally moving underneath you. You could be 30 miles out, perfectly happy on cellular, and 15 minutes later, you're in a complete dead zone. The system has to hand off to a totally different technology, and it has to do it instantly. That requires marine-grade hardware and some pretty sophisticated network intelligence.
Okay, so to make this tangible, let's use that fantastic real-world example from the sources. Imagine a yacht leaving Fort Lauderdale, heading out toward the Bahamas. That short trip, that really shows the whole technological journey, doesn't it?
It really does. So they start near the Florida coast, and they're relying on fast, cost-effective Maritime LTE or 5G. But as they head east, that cell coverage it drops off a cliff. So they absolutely must transition seamlessly to marine satellite internet to stay connected in open water. Then when they arrive at a port in the Bahamas, say a busy marina, they'll likely want to connect to a local high-speed marine Wi-Fi system while they're docked.
And the key insight there is that without a managed hybrid system, those handoffs, they're not smooth at all. They lead to dropped service. A video call freezes, a nav update fails, or your remote desktop just kicks you out. The system has to anticipate and manage all that automatically. Okay, this is where it gets really compelling. To see why the hybrid solution works so well, we have to look closely at the three pieces feeding into it. Let's start with the big one, the one you absolutely need for blue water cruising. Marine satellite internet, this is your offshore safety net.
It is, unequivocally, the offshore backbone. It gives you that global, guaranteed connectivity once you're beyond coastal limits. But like you said, the technology itself has gone through this massive paradigm shift. You're not dealing with the old, slow satellite internet anymore.
Right.
And this is a critical aha moment for you, the listener. It's the difference between the legacy geostationary systems, or GEO, and the modern low Earth orbit systems, or LEO. They're based on completely different physics. GEO satellites are way up there, about 36,000 kilometers high. That massive distance means you get very high latency, typically 600 to 800 milliseconds, and speeds are slow, maybe 5 to 30 megabits per second. They're fine for older commercial shipping, but they're just terrible for anything interactive.
Okay, so how does that massive drop in latency from, say, 800 milliseconds with GEO down to maybe 40 with EO, how does that actually feel to a user? Can a captain really notice that difference, or is it just a number on a spec sheet?
Oh, you feel it instantly. With 800 milliseconds of delay, you've got almost a half-second lag in a conversation. Video conferencing is just miserable. VoIP phone calls stutter. Even loading a simple web page feels sluggish because that request and response cycle takes so long. Streaming just buffers constantly. Now compare that to LEO, because the satellites are so much closer, only 500 to 1,200 kilometers up, that latency drops to just 20 to 40 milliseconds. That is virtually real time. It means responsive video calls, you can have lag-free gaming if you want, smooth remote desktop access. LEO has, well, it's pretty much replaced GEO for high-performance yachts because the experience is now just like a high-quality connection you'd get at home.
That responsiveness changes everything. It changes how you can actually use the boat. Now let's talk about the speedster that keeps the monthly bills down when you are close to land. Maritime LTE and 5G.
Right, so Maritime Cellular is the financial champion here. When you're within range, it is exceptionally fast, often even faster than a LEO, and it is dramatically more cost-efficient than paying for satellite airtime. That's why it gives you the best performance per dollar.
But it has some serious limits.
It has very strict limitations, and this is where that ocean reality kicks back in. Coverage diminishes very quickly offshore. You know, a lot of providers might advertise 40 miles out, but that's a perfect world scenario. The real range is all about line-of-sight physics. An antenna mounted way up on the mast of a big yacht might see 30 or 40 miles, but an antenna mounted low on a cruiser's flybridge, you might only get reliable coverage 15, maybe 20 nautical miles out.
So the range isn't a guarantee at all. It's
Yeah.
tied to how high your antenna is and, the simple curvature of the Earth. You just lose sight of the tower faster.
Exactly. The key takeaway here should be that LTE and 5G should always complement marine satellite. They should never replace it. Using them together gives you the best speed, and it controls your costs by saving that expensive satellite data for when you truly need it.
Okay, and that brings us to the third piece, the supplemental tool, marine Wi-Fi. This is for when you're tied up at a marina.
Yeah, and it plays a crucial but limited role. It's fantastic for very specific things, system updates, downloading huge chart files or media libraries, and it massively cuts your costs while you're physically docked. But, and this is a big but, marina Wi-Fi is notoriously variable. The speed, the reliability, you're often sharing it with dozens of other boats. And critically, it's useless the second you untie the lines. It should never, under any circumstances, be considered the primary connection for a boat that's underway.
So what does this all mean? We've got these 3 different data sources, satellite, LTE, Wi-Fi. They all have different speeds, different costs, different ranges. The magic, the synergy that the sources talk about happens when you combine them all into one intelligent system.
This is the genius of the hybrid mechanism. All of those connections feed into a central marine router, which is basically the boat's connectivity brain. And this brain does 2 critical things: failover and bonding.
Let's define those for the listener, because this is really the core value here.
Absolutely. So failover is the baseline. If your main connection, let's say LTE, drops completely, the router instantly and automatically shifts all your traffic over to the backup link, like satellite. You don't even notice a disruption. But the really powerful technology is bonding.
Okay.
Bonding lets the router combine the bandwidths from 2 or more active links at the same time. So say you have a weak LTE signal and an active LEO satellite link. The router can bond them together. It gives you one connection that's faster and much more robust than either of those links on its own. This is what maximizes your uptime. It's what prevents video calls from dropping mid-sentence and keeps your remote desktop stable no matter what you're doing.
That sounds like a dream for performance, but we talked about cost efficiency with LTE. We need to see that in action. Do the sources give us a real-world example with, actual numbers? Because I know owners are always looking to trim those big satellite bills.
They give a fantastic one, and the numbers are pretty compelling. It's a case study that tracked a 70-foot yacht operating mostly along the U.S. East Coast. So by putting in an intelligent hybrid system, one that automatically prioritizes that fast, cheap LTE whenever it's available, and only use the expensive satellite for the deep offshore passages.
They just maxed out the use of the cheap data while still keeping the connection live?
Precisely. That vessel cut its monthly satellite cost by more than 40%. 40%. That's like getting a 4 months of service for free every year just by having smart architecture. That's a huge financial incentive to move away from relying only on satellite.
That is a massive win. Okay, let's shift to the practical side. If you're looking at one of these systems, what are the common friction points that owners run into, and how does the hybrid approach solve them?
We can group them into 3 common pain points from the sources. The first and the most common complaint is dropped video calls and unreliable VoIP. That's usually caused by the latency and handoff issues of a single satellite system. And the solution is that bonded hybrid system we talked about, which smooths over those little gaps.
Right.
The second is the one we just covered, excessive satellite costs. And again, the solution is prioritizing LTE near shore, saving that satellite data for when you're really offshore.
And the third one, which I imagine plagues any boat with guests, is just slow guest internet. A guest is trying to stream 4K movies while the captain needs to download critical weather data.
Exactly. That chaos is usually because there's no traffic management on the network. The fix for this is implementing VLANs and bandwidth controls, which is a really high-value bit of knowledge for you to have.
Okay, let's pull back the curtain on that jargon. What are VLANs and traffic shaping in simple terms?
So a VLAN, or a virtual local area network, just means we create separate, walled-off networks on the boat, usually with the same hardware. So one for guests, one for operations, one for the owner. This makes sure guest traffic is physically segregated from, say, critical navigation data. They never clash.
So they stay in their own lane.
They stay in their own lane, and bandwidth controls, or traffic shaping, is the intelligence on top of that. It's a fancy way of saying we guarantee that GPS data, safety systems, and the owner's connection always get the fast lane. Meanwhile, Netflix streaming for guests gets automatically throttled or put in the slow lane when the network gets busy. You control the experience, not your passengers.
That kind of segmentation seems non-negotiable for any serious cruising. Speaking of costs, outside of that 40% savings, what's a ballpark for these systems? What do they actually cost per month?
Monthly service costs are really variable. They can range from about $250 for a low-use coastal cruiser up to well over $2,000 for a large yacht that needs high-end, unlimited LEO, and multiple 5G plans. The primary driver of that cost is always how much high-speed satellite data you're consuming.
So if you're choosing a provider, what should you look for beyond just the data plan? Because this is clearly about more than just gigabytes. It's about the whole system.
You have to look for deep expertise and dedicated support. The right provider offers marine-grade, fully certified hardware, systems that are actually rated to withstand shock, vibration, and salt water. They need to have proven hybrid system expertise, good US-based technical support who actually understand these systems, and the ability to scale your plans up or down as you need.
And this is where we hit that major red flag from the sources. Avoid anyone trying to sell you land-based equipment for a boat if it doesn't have marine certification.
Absolutely. That equipment is not engineered for the constant motion or the corrosive environment. It will fail. And it will probably fail at the exact moment you need it for critical communication or navigation. You're paying for reliability at sea, and land-grade gear just can't deliver that.
Finally, just quickly walk us through the installation. It sounds pretty complex.
It's systematic. It starts with a full connectivity assessment to figure out your exact needs. Then, the antennas have to be positioned perfectly. For LEO systems, that means a clear view of the sky, avoiding radar interference, compensating for blockage from masts. The routers are then configured for traffic prioritization and failover. And the final, most crucial step, testing the entire system while the boat is actually underway to make sure it performs during those critical transitions.
So to summarize the key takeaways from this deep dive, marine internet needs specialized hardware and very intelligent design. The best system for boats in the US is always a hybrid one. LEO satellite is absolutely essential once you're offshore. LTE and 5G are your high-speed, cost-saving tools near the coast. And marine Wi-Fi is just a supplemental tool for when you're tied up at the dock.
And if we connect this to the bigger picture, today's maritime internet systems are completely different from what they were even 5 years ago. They're intelligent, they're resilient, and they fully support modern life at sea. Everything from 4K streaming and video conferencing to running secure VPNs for remote work. The days of struggling for data are really over for boats that use this hybrid architecture.
And that leads us to our final provocative thought for you to chew on. Considering that modern LEO speeds are now comparable to high-end residential fiber internet, and that these hybrid systems can guarantee seamless, reliable remote work pretty much anywhere, what does this mean for the future of personal boat ownership? Has the truly unplugged voyage, the one where you're unreachable for weeks at a time, has that permanently disappeared from the recreational boating world? Something to think about the next time you drop anchor. Thanks for joining us for the deep dive. We'll see you next time.